Hello everyone, my name is Alexis and today I'll be giving a math lesson on how to use the chain rule. Before we begin, I want to give an introduction on composite functions, which we'll be using in the chain rule. And you might have already seen this before, but it's basically a function inside of another function. So let's say we have this example here where you want to find f of x, except x will now be g of x. You do this by plugging in x plus 4 into x to the power of 5. Then, to find g of x, where x is now f of x, you would do the same thing as you did with a. You would plug in x to the power of 5 into x plus 4. So, what do you want to do if you want to find the derivative of a composite function? Well, this is where the chain rule comes in. And one good way to summarize this rule is that it's the derivative of the outside function, keeping the inside the same, then you multiply it by the derivative of the inside function. To show you how the rule works, I have this example here. My first step is usually to identify which is the outside function and which is the inside function. As you can see, f of x is our outside function and g of x is our inside function. After I have identified the two functions, then I'll begin to use my chain rule. Since the chain rule states that you need to find the derivative of the outside function first, we'll then take x to the power of 6. We'll move 6 down as a constant using the constant rule, and then use the power rule and subtract 1 by 6 to get to the power of 5. We also want to make sure that we keep the inside function the same. Then, once you have done that, you can then start to find the derivative of the inside function. And here we get 10x to the power of 4 plus 4 using the same rules we did. You can simplify your answer, but I think it's best if you leave it alone because then it gets a little complicated. Here's another example where the square root is the outside function. Well, we also know that to rewrite square root of x, we can turn it into x to the power of 1/2. By doing this, you make it easier to find the derivative of the outside function by using the same constant rule and power rule. So we can move 1/2 to the front and then subtract 1 from negative 1/2. Again, making sure we leave the inside function alone. Then we can multiply it by the derivative of the inside function, which leaves us with 2x. And since the derivative of our outside function is to the power of negative 1/2, we can simplify our answer further by bringing this down to the denominator and then multiplying our inside function into the numerator, and then eliminate the 2 and get our final answer. For example 3, we have natural log as our outside function, and if you remember, the derivative of a natural log is f prime equals to 1 over x, and using the chain rule we do the same for this outside function. We turn it into 1 over x, and x will be g of x, keeping it the same. So you should have 1 over 5x squared minus 8x plus 3, and then again you find the derivative of the inside function, 10x minus 8, and multiply it by the outside function derivative. Similar to the last problem, we can again simplify our answer and multiply the inside function by the outside function and move the inside function into the numerator, and this should be your final answer. So for example 4, we have this composite function where it is e to the x minus 5 over 6x plus 3 over 9. You would think that you could only use the quotient rule for this, but since we see that there is an inside and outside function for both the numerator and denominator, we have to use both the quotient rule and the chain rule. So to begin solving this problem, when we use the quotient rule, we find what our f and g of x are. In this case, f is equal to e to the x minus 5 and g equals 6x plus 3 to the 9th power. Now, this is when we start to use the chain rule when we find our f prime and g prime. We'll find the derivative of e to the x minus 5, and since e to the x, the derivative of that is e to the x, we keep that the same and keep the inside function the same, which is x minus 5. Then multiply it by the inside function, and the 5 cancels out, and x turns into 1. To find g, we will have 6x plus 3 to the 9th power. For our g prime, we'll use the chain rule again, and we'll move the 9th power down as a constant and then subtract 1 from 9, leaving you with the 8th power. And then when we find the derivative of the inside function, the x and 3 cancel out, leaving you with just 6. So to put that all together, you begin by plugging in the f, g, f prime, and g prime into the quotient rule equation, and you'll be left with this. I also want to note that before I plugged in f prime and g prime, I simplified them and multiplied the derivative of the outside and the inside function. So for example, g prime, I multiplied the constant 9 and 6 to get 54, 6x plus 3 to the 8th power. It is possible to continue simplifying this answer, but you also risk sort of messing it up in the calculator like I have, so it's best to just leave it as is. So for this last example, I have an application problem that reads, the total cost in thousands of dollars of producing X lipsticks per week is given by this function. The number of lipsticks produced per week X varies within the range of 0 to 12. Part A of this example is to find the derivative of the cost function. Similar to another problem we solved in the beginning, there is a square root with 2x plus 5. We can turn that into the power of 1/2 to make it easier to find the derivative of the outside function. So just like before, we can move 1/2 down as a constant, subtract 1 from the power of 1/2 to get negative 1/2 power, and then multiply it by the derivative of the inside function, in which x cancels out and 5 turns into 0, leaving you with 2. Because the original equation had a fixed cost of $100, we still need to find the derivative of that, but since there's no x variable, that $100 turns into 0. Now we can simplify our answer, moving the derivative of the outside function into the denominator and multiply 2 into the numerator. If we cancel out the two constants, we are left with this answer, which is the derivative of the cost function. Part B of this application problem asks, what is the cost if you produce 7 lipsticks? Since we already found the derivative of the cost function, all we need to do is plug in 7 as x into the equation. You can plug this into the calculator and your answer should be 0.23, and the correct units are thousands of dollars. So, to interpret this answer, you should say, to produce 7 lipsticks in 1 week, it will cost 0.23 thousands of dollars. And that's the end of my video. I hope you learned a lot about the chain rule. I also want to note that I made an error when I was talking about the constant rule. The constant rule is true when we turn a constant like, let's say 100 into 0, that is the constant rule. But when we were using the power rule and I was explaining that you move the constant to the front. That is not the constant rule. That is just a part of the power rule. So I apologize for that. But yeah, I just want to correct that mistake.